दोस्तों जय हिंद जय भारत नमस्कार. In last session number 10 we understood the characteristic of charge. One is called a positive charge and second is called a negative charge, and if we keep the charge in a three-dimensional way, we have found out, we understood the effect of one charge particle on the second charge particle, and it is if you keep the two charge particle at the distance r1 and r2, one charge particle with a distance r1 and r2, the effect from the center, it going from center to away and away, the field line strength is been decreased. That is called under root that is inversely proportional to the square of the distance. That means if you go away from the charged particle, the field strength is been decreased by a square of the distance. In topic number 11 we will try to understand the electric field lines and its characteristic. What is the electric field lines? Let me try to explain topic number 11, electric field lines. You can see I have kept one charged particle in the center of the sphere and it's supposed to generate the lines. You can see very well the lines from the center of the charged particle. The red lines are stronger and blue lines are medium stronger, and if you go away and away the yellow lines, the field becomes a weak, and then we declared as a weak electric field. But the field is been generated, the first invention of these lines. Please listen carefully. The first invention of these lines are been done by Mr. Faraday, the known scientist. Mr. Faraday declared these are the field lines. But Faraday declared these field lines as a force. Initially, he declared this is the force of the charged particle. But force is not a correct word. Later on, it will be declared as a field lines. So a charged particle generates the field lines. This is the how the field lines are being declared and invented by Mr. Faraday. Going further, the field lines may be a magnetic. Once you keep the charged particle, it's supposed to generate the force, and force is supposed to generate the magnetic, and magnetic convert into electric fields. That means these lines in this, you can declare these lines may be a magnetic or electric, but these are the field lines. Please listen carefully. This particular arrow, what we have mentioned in this particular picture, are declared any charged particles generate the electric field in form of field lines. These field lines may be a magnetic or it may be an electric. Moving further, you can see here on the left side, if you see carefully, the charged particle generate the field lines in the outer mode. The lines are coming out, and that is why it is called a positive charge. Please listen carefully, maybe an objective question. The lines coming outwards, hence this charge is declared as a positive charge. And on the right side, you can see the field lines are coming inner to the charged particle, and that is why it is been called as a negative charge. What is the difference between a positive charge and negative charge? From the picture, you can see the outward lines indicate the positive charge and inward lines indicates the negative charge. Now I have a two charge. One is called a positive charge and second one is called a negative charge. And both the charge comes together, they forms a particular um, uh, particular cylindrical type of arrangement. And you can see the positive charge and negative charge both are called a dipole. Di means two, pole means axis. That means you can see here there are two different polarity charged particles are being connected called a dipoles. You can see very well the first charge particle outwards and the second charge particle on the right side is inwards. That means one is positive charge and second is negative charge, and this is declared as a one dipole. This particular phenomenon we need to understand when we are going in the next chapter for the electric flux. We need to understand from the dipole, and dipole is nothing but you can see the combination of positive and negative charge. One is outer, one charge is delivering the lines outer side and one is inner side, that is negative charge, and both combination is been declared as a dipole arrangement. Now moving further, you can see if you have a dipole type of arrangement, you can see one line is going out and second one is in. You can see none of the line is intercepting each other. If you keep the two different charge particle together, they form they form the dipole arrangement, and you can see here one is outer line and then second one is inner line. None of the lines are been intercepting each other. The big question is, if I have only one charge particle, if I consider only a positive charge particle or negative charge particle, these lines will transfer the electric field and be declared as a infinite line. Up to what distance this line will go, it's an infinite line. Let me recall all this. The point number one, field lines properties. The field lines start from the positive charge and end at the negative charge. We have seen in the previous slide, if there is a single charge, what I have mentioned, if there is a single line, it may start or end at infinite distance. There is a infinity. We called it as a infinity. In a charge-free region, electric field lines can be taken to be a continuous curve without any break. If you have a single charge and there is no other charge available in that particular region, that is called a charge. Electrical lines can be continuous as a electric field lines can be taken as a continuous without any break. Two field lines never cross each other. We have seen in the last particular slide, the two field line never cross each other, and electrostatic field lines do not form any closed loop. That means it generate from the positive charge, it will go to the negative and come back. It will never go from the positive and come back to the positive. No, they will never form a closed loop. They follow from the conservative nature of the electric field. It generates from the positive and at the negative. It will never come from positive and again come back only to positive. No, that is not, they will not form any closed loop. So these are the four best property of the electric field line. Student has to remember this. If you someone asks you what is the field line property, you can say 1, 2, 3 and 4. Very easy to understand if you understood the last sheet picture. And then the next session we will try to understand this particular discussion is very much important for to understand the electric flux and dipole arrangement, what we are going to discuss in the next session. So please try to remember this dipole arrangement. Thank you. Dhanyawad.